Okay, here we go. This is find the length of the third side if necessary, round to the nearest tenth. Notice across from the 90-degree angle we have the hypotenuse. Need to write that down. Let's put the hypotenuse is always C. Remember, the hypotenuse is always C. So I'm gonna name this leg B. I'm gonna name the other leg A because I am looking for A. A equals the square root of C squared minus B squared. I just need to fill that in now. The square root of 14 squared minus 10 squared. At this point, I keep solving or simplifying. That would be equal to the square root of 196 minus 100, or the square root of 96. I could put that on the calculator, which I will be using the computer's calculator, so it's a little bit different. I already have the answer there, but hey, it's a little bit different. I was practicing using the computer's calculator. So I put 96 and I put the square root, and it gives me that is 9.79. Remember, it says to round to the nearest tenth, so I am going to write 9.8. 9.8. It's approximately 9.8 units. Okay, and that would be the answer to the first problem in the test review. Okay, give me a sec. The second problem is this: find the length of the third side if necessary. Write it in simplest radical form. Again, I want to identify my parts. In this case, A is the same formula. A is equal to the square root of C squared minus B squared. So A squared plus B squared equals C squared. That's where we're deriving this formula from. Remember, it's the Pythagorean theorem. I just took a shortcut. And the shortcut will give me A is equals the square root of C squared minus B squared when I solve for A. So in this case, it's 9 squared minus the square root of 17 squared, which is 81 minus the square root of 17 squared. Just cancel each other, so it's just 17. That equals the square root of 81 minus 17, which gives me 64. And the square root of 64, which is a perfect square, remember that, that's just 8. So A is 8, or 8 units, whatever the units are. In this case, they didn't give me a specific unit, so it will be 8 units. Number 3, find the missing side. Leave your answer in simplest radical form. Notice I'm given that the square root of 13, that's C. We are looking for X. So again, the same formula. A is equal to the square root of C squared minus B squared. So C squared is the square root of 13 squared minus the square root of 5 squared. Remember that the square will cancel the square root. Just gives me the square root of 13 minus 5. That would be the square root of 8. You have to put it in simplest radical form. So I must factor 8. 8 is 2 times 4, and 4 is 2 times 2. So that equals the square root of 2 times 2 times 2, or 2 cubed, right? But I write it as 2 times 2 times 2. Now I'm looking for pairs. Notice I have a pairs of 2, so I'm gonna take that pair out, and I just take 1, 2, because one pair of 2 is 1, 2. For every pair, you take that number out, and whatever does not have pairs, leave it inside the radical sign. So A equals 2 square root of 2 yards, right? Square root of 2 yards. And that would be the answer to number 3. Okay, moving on. State if each triangle is acute, obtuse, or right. The formula, remember, it's c squared is less than a squared plus b squared. Then we have an acute triangle. If c squared is equal to a squared plus b squared, then we have a right triangle. If c squared is greater than a squared plus b squared, then we have a obtuse, or an obtuse triangle, right? So here we identify who would be C. C would be the greatest side, the longest side. So in this case, I put 14 square. It's equal to 12 square plus 9 squared. And I solve that. 14 squared is 196. I put equals for now. I check, that's 144 plus 81. Do the math. And I check to see which one is. So notice that 196 is going to be less than whatever that number is. If I add it, that's 5 and 12. It's 225. So 196 is less than 225. Therefore, that tells me that this triangle is an acute triangle. I do the same for number 5. I look for the longest side. In this case, it's 13. That's going to be my C. So 13 squared, it's equal to 12 squared plus 2 squared. Do the math. 169. 12 squared is 144. 2 squared is 4. So plus 4, that's 148, right? Okay, so I see that 169 is greater than 148. So I put the sign there, greater. That means that this is an obtuse triangle. Okay, that concludes that part. Then we move on. The next part, it's find the missing side round to the nearest tenth. I'm given one side and then given an angle, so I cannot use Pythagorean theorem. I need to use the trigonometric ratios. I want to identify who is who, so I see I have the hypotenuse next to 73. The angle is the adjacent. The hypotenuse can never be the adjacent, so I'll write my clue here, SOHCAHTOA. Remember that. In this case, I have the hypotenuse and it's adjacent, so it would be cosine. So the cosine of 73 is equal the adjacent, which is x, over the hypotenuse, which is 10. Bring the 10, since you're dividing by 10, so the opposite of division is multiplication, so you multiply by 10 on both sides. So 10 cosine of 73 degrees should give me x. Go to the calculator. Make sure your calculator is on degrees. Hopefully this one is on degrees already. Here is my trigonometric ratios because it's a little bit different. So let me check. Hold on. So I put 73 cosine is that times 10, right? Times 10. So this one, it's easier when you do it on your TI Inspired. In this one, I have to figure it out. So I put that first and then multiply that times 10, and it gives me that it's 2.9. 2.9. So my answer for X is approximately 2.9 units. And that would be adjacent. 2.9 units, that what the short leg there will measure. Going to the next, again my angle, which is 24 degrees. I see I have the opposite. X would be in the hypotenuse. So opposite and hypotenuse, that would be what? That would be sine ratio. So I have opposite and hypotenuse, I would use sine ratio. So sine of 24, it's equal to the opposite, which is 13 over x. Now to solve for x, remember I'm dividing by x, so I have to multiply by x on both sides. So basically bring x to the front of the sine of 24 and take that sine of 24 and put it down where the x was. So x would be 13 divided by the sine of 24. You put that on the calculator. And it gives you that, let's see, there you go, the 31.96. So if I'm going to round to the nearest tens, that 6 brings the 9 up 1, so that I bring it to 10, so I'll be 32. So it's approximately 32 units. 32 units. That x would be 32 units. So that's what the hypotenuse should measure, around or very close to 32 units, okay? So remember. So let's take it down to number 8. Still the same thing. Still the trigonometric ratios. Identify my angle. Identify my sides. I have 12 is the opposite. X in this case is the adjacent, because there's my hypotenuse across from the 90-degree angle. So X is my adjacent. So opposite and adjacent would be what? The tangent ratio, right? The tangent ratio. So let's see. The tangent of 44 degrees is equal to the opposite, which is 12, over the adjacent, which in this case is x. It happens as before, x fell down in my denominator, so I multiply by x, so just switch sides to bring that x to the front and the tangent 44 to the x. So x is 12 divided by tangent of 44. At this point, I have that x is approximately, and I go to my calculator, clear it, make sure it's cleared. 12 divided by 44 tangent in this case, right? That's tangent, so it's 12.42, so 12.4, approximately 12.4 to the nearest 10. That's 12.4 units. That's my answer for number 8. For number 9, the same. I look for my angle, identify my part. So I have, here is my hypotenuse across from the 90-degree angles, and then opposite to the angle I have is 10. That's opposite. Opposite and hypotenuse, that would be the sine ratio. So the sine of 46 is equal to 10 over x. 10 over x. And repeat the same process. So x is equal to 10 divided by sine of 46 degrees. Go to my handy dandy calculator. Clear it. And just put it in. That's approximate 13.9 units. And that would be my answer for that one. Okay, that would be my answer for that one. Pretty good. Okay, directions. Find the missing side lengths. Leave your answers as radicals in simplest form. Notice now we're talking about a special right triangle. Here I have a 60-degree angle. So I need to leave it in radical in simplest form. The formula 30, 60, 90. Right under 30 or the short leg we have x. Under the long leg we have x times the square root of 3. And under the hypotenuse we got 2x. Okay, or the hypotenuse will be 2x. That's across from 30 is x, across from 60 x square root of 3, across from 92x. Okay, here we go. So here we have 30. So the n would be x, right? The n would be 2x. And across from the 60 we have x square root of 3. So that's across from the 60 we have x square root of 3. So those two numbers must equal each other. So I could set up my equation and solve for x. Once I have x, I have n. And then double it for m. So x square root of 3 equals 3 square root of 3 divided by 2. To solve, I must divide by the square root of 3 on both sides. Remember that. So, I'm going to change colors here so you can see what I'm doing. So divide by the square root of 3 here, divide by the square root of 3 over here as well. Notice this one cancels or becomes 1. This one also becomes 1. So that means x, or 1x, equals 3 halves. So now I have x. If I have x, x is across from 30, so that means n is 3 halves. All I have to do to find what's across from 90 is double x. X is 3 halves, so double it. So that would be 2 times 3 halves. Or 2x equals 2 times 3 halves. Notice the 2, you can cancel actually the 2 right there. And it leaves you as 3. Or you could just multiply 2 times 3 is 6. 6 divided by 2 equals 3. Okay, so that's what that is. 2x equals 3. So m equals 3. So n equals 3 halves. That would be the answer for n. M would be 3. Okay, let's move on to number 11. Again, it's the same formula. That's still a 30, 60, 90. Notice I have the long leg, so I have what is across from 60. So that would be x square root of 3. So I could set up my equation. X square root of 3 equals 3. What I have to do is again divide by the square root of 3 on both sides. Now here's something important. That one cancels because it leaves you 1x, but you cannot leave the radical in the denominator. Okay, so you cannot leave the radical. Notice since I put y, it's in the real answer is y, but in my formula is x, so I'm going to change it for now for x. When I answer, I would say y equals whatever x is, right? So notice I have to rationalize. So to do that, I multiply by the square root of 3 over the square root of 3, which is a different one. So 3 times the square root of 3 is 3 square root of 3, and then 3 times 3 is 9, so the square root of 9 is 3. So notice now you have 3 outside on the top, 3 outside in the bottom, so I could cancel those, and it leaves me with a square root of 3. So that means that x is the square root of 3 in the formula, so my answer for y is the square root of 3. And then I'm going to look for the hypotenuse, what's across from 90, is just double it, 2 times the square root of 3. So y equals the square root of 3, and x equals 2 square root of 3. And that would take care of number 11. Number 12, that's a 45, 45, 90. Let me write the formula here. Yeah, 45, so nm, so remember that I'm looking for n should be the same as the other side, because that's the only isosceles right triangle. If it's both 45 degrees, then those sides that are opposite to the angles, they must both be the same, right? They must be congruent. So that's why the 45, 45, 90, whatever on across from 45, you only have x, and then across from the 90, which is the hypotenuse, would be whatever the side times the square root of 2. So in this case, n is easy, it's 5 square root of 2. It's already given. All you have to do now is multiply that times the square root of 2, because it's across from 90. That's to find m. So you have 5 square root of 2 times the square root of 2, which is 5 square root of 4, which is the same as the square root of 4 is a perfect square as 2, so it's 5 times 2, which is basically 10. Therefore, m equals 10. Okay, and that takes care of that. This is the hardest problem, which is not that hard in the test. So here we're given first a 45, 45, 90. We're looking for x in the bottom. So remember that's a 45, 45, 90. So because that's x times the square root of 2 in the formula, so I set it up that way. So I would say that x square root of 2 equals 10 square root of 6. Remember, the formula says that across from 90, you take the side and multiply times the square root of 2. So here I set up my equation, divide by the square root of 2 on both sides. Once I do that, the same thing happened as before. It gives me that x, and 6 divided by 2 is 3, so it's still under the radical, so it'll be 10 square root of 3. Now, what I found is part of the puzzle. I found that side, so I found both sides, because remember, both sides on the 45, 45, 90, or both legs measure the same, so that measures 10 square root of 3. Well, if that is 10 square root of 3, according to the 30, 60, 90, if I'm going back to the short leg, I'm going to divide by the square root of 3. That will cancel the square root of 3, and it gives me that 10. So 10 is the short leg, and to go from there to where to the answer I'm looking for, which is the hypotenuse of that 30, 60, 90, I will just double it. So multiply by 2. So 10 times 2, it's 20. So 20 would be my answer. Okay? And that would solve number 13. That would be the hardest problem. Here we go. Now we have to find the angle. And we're going to still use the trigonometric ratios. And we want to solve to the nearest degree. So we want to leave the angle in the nearest degree. So we're going to use the trigonometric ratios. So I'm going to write my SOHCAHTOA right on top there. Identify what I have. I have the hypotenuse to the question mark, which is the angle I'm looking for. 7 is the opposite, 20 is the hypotenuse. So sine inverse of the opposite divided by the hypotenuse, and I'm gonna put that on the calculator and it will give me my answer. So let's clear it. Once we clear it, we put 7 divided by 20, and we want the inverse. I want to put that in parentheses in my computer's calculator. So hold on, 7 divided by 20. And that one I want the inverse. So there it is. So it's 20.4, so that would be 20 degrees. 20 degrees would be my answer for that, because I'm rounding to the nearest whole or to the nearest degree. Number 15, and we're almost finished because there are how many questions? 19. So number 15, I could use anything I want because I have all the sides. I'm looking for the angle, so I'm gonna identify. I have my opposite hypotenuse. I'm gonna use the same thing. So opposite and hypotenuse, keep it simple. That would be the sine inverse. Remember, the inverse is that -1 of the opposite, which is 72 over 90. And that's what I'm going to put in the calculator. Make sure you clear it. I think you have to open a parenthesis because you're going to divide in, and again, it's different in the TI Nspire, but here I have to put a parenthesis to put the 72 divided by 0.8. 72 divided by 90 is 0.8, and then I'm gonna go and get the sine inverse because it's backwards on this calculator, and it gives me that it's 53.1 or 53 degrees. So that's 53 degrees. That's my answer. Now we go to number 16. Here we have the word problems, right? What is the angle of depression between a woman in a hot air balloon that is 50 feet off the ground and her friend that is 100 feet from being directly underneath the balloon? Okay, let me try to draw this here, okay? 50 feet, boom, boom, boom. Let me bring this down. Okay, let me draw the balloon. Make it look real, you know. Little trapezoid there. Okay, I'm gonna try to draw this line down. It's hard because I'm using one of those tablets. Oops, that's the ground. Well, ground is straighter than that, so let's make the ground straight, or at least as much as I can. 50 feet off the ground is the balloon. Let me see. I'm gonna try to draw. Man, I cannot draw down straight. Anyway, take that as straight line down. That would be 50 feet off the ground. Now, her friend, she's 100 feet from being directly underneath the balloon. Here is the line of sight horizontal to the ground, and that's the horizontal, right? She's 50 feet off the ground. Her friend is 100 feet from being directly underneath. Directly underneath would be about down right there. But now she's not there. She's 100 feet away, so I'm gonna draw her over here. Okay, so there is her friend. When she looks down, boom, I'm gonna try to make it straight. Let's see, so don't judge me, okay? There we go. Okay, so what? That's 100 feet from being directly, and here is the angle of depression. That's the angle of depression from looking, when you're looking from the balloon down, that's from a horizontal line. Now that would be the same as the angle of elevation if her friend would be looking up at her. Okay, so that's the same. So I'm gonna use this one down here, which is the angle of elevation, which would be the same because of alternate interior angles. That's the opposite. Here's my 90-degree angle. That's the adjacent. And I'm looking for this angle right there. So that would be an inverse, right? So that would be the tangent inverse of the opposite, which is 50 over 100. Okay, and that would give me this, which is one. They give me the bottom, which is the same as the question mark right here, which is what I'm looking for. So I go to the calculator, parentheses, clear it, parentheses, 50 divided by 100, close parentheses, and then that would be the trigonometric tangent inverse, and that would be about 26.56, 26.5, so about 27. degrees. That would be my answer. Just remember, I'm rounding to the nearest whole or nearest degree, so I have to go up one. Here's another one. A slide of the playground starts 12 feet off the ground and has an angle of elevation with the ground of 25 degrees. How long is the slide? So here's the ground. Here's my slide. The angle of elevation from the ground is right there, is 25 degrees. So I write that down, and man, I cannot write a straight line down. It's very hard on the tablet. There we go. That's close enough. 12 feet off the ground, and I'm looking for the slide. This is the slide right here. So that's what I'm looking for. So X. There's my 90 degrees. So this time that's the hypotenuse. This is the opposite. So I'm gonna go opposite over hypotenuse. That would be the sine ratio. So, right? So sine ratio. So the sine of 25 equals 12 over x. And we've already solved at the beginning some of these. Just switch sides. So x is equal to 12 divided by sine of 25. Again, put in the calculator. And that you have to round to the nearest tenth because we're talking distance. Let's see here. That's about 28.4. It's about 28.4 feet, right? Because we're talking about feet. So that would be my answer. That's the length of the slide. Two more, guys. Two more. One more here. 18. You start driving west from a point. So you're here. Boom. You go west for 5 miles. Then you're gonna turn left and drive south. Let's see if I can make that line. Oh my gosh. Well, drove south. That was 8 miles. Okay, so now, what is the straight line distance from your starting point right there, I guess, to the end point, right? Which is right there. So what is that distance? Boom, 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 right there. Okay, so that is Pythagorean theorem. I'm looking for C. So C equals the square root of a squared plus b squared, remember? So that's pretty neat. So that is 5 squared plus 8 squared. That's what? 25 plus 64. That's what? 89. So the square root of 89, whatever that is, I'm just gonna put it on the calculator. What is the square root of 89? So 89 square root, it's 9.4. So about 9.4 miles. It's about 9.4 miles. That's the total distance from the beginning to the end, a straight line. All right, one more. Now, if you worked your Delta Math, you worked this problem already. In Delta Math, they didn't give you the drawing. I gave you the drawing right here. So basically, you have the ladder, 52 feet. You have how high it goes up the house, 48 feet. So that is Pythagorean theorem. Again, I'm looking for a leg. Here is I want to see the distance before I even start from there to there, because that's the leg. So I am going to use what? A is equal to the square root of c squared, or 52 squared, minus 48 squared. Go to the calculator and check that out. In the TI Nspire, you just put it just like that. Here I gotta work it, so let me see. We got 52 squared. That's 2,704. 2,000 minus 48 squared. That's 2,304. So the square root of the difference of those two, I'm going to put it in the calculator. So I want to make sure, minus 2304, that gives me that is 400. So it's equal to the square root of 400. So what is the square root of 400? That'll be 20. So that's an even 20. So now I know that's 20 feet. Now that I know it's 20 feet, it says if Young grabs a ladder at its base and pulls it 3 feet farther from the house, it looks something like this. I know I cannot draw straight on with this tablet. Okay, so I want to know the distance. So he pulls it 3 feet more. So now it's 23 feet in the bottom. I want to know how far up the house it will go. Remember, the ladder does not change size. It will still be 52 feet. So that remains constant. So I'm going to use this exact same formula. A is equal to the square root of 52 squared, but this time I'm going to use minus 23 squared. Once I have that, I will have found my answer. So that's 2,704 from the previous, minus 23 squared. That's, let's see, that's 529. So I do the math on that. 2,704 minus 529. Notice I bring my square root down, my radical sign, I bring it down. Don't forget that, because we haven't solved that yet. So I'm going to solve this. 2704 minus 529. That gives me, that is 21, or 2,175. So we're looking for the square root of 2,175. Whatever that is, that's my answer. So I go to the calculator and get that, and it's 46.6 feet up the house. So notice this, the answer is not 45. Well, it is not. It's 46.6 feet. And that is the question. So that's the answer to the question they're posing. So at this point, I have 100 on my test. Hoorah! Okay, so see you soon. See you this week. Make sure you study. If you need to retake that test and do well, okay? So I'll see you soon.